Okay, with part 3, you have to draw the structural formula for each molecule, include the shape, bond angles, polar, nonpolar. What is helpful for this is having the PhET simulator open. If it'll work, this one. Okay, there we go. So I'm just going to have that ready, available. Okay, so for the first one, CH4, its total valence is 8. This is your very standard tetrahedral shape. If we count up valence or count up electrons on the structure, it's 2, 4, 6, 8. So you already have 8. You don't need to add double bonds. This is tetrahedral. This is going to be nonpolar. This tetrahedral is a very nonpolar shape as long as everything is the same bonded to the center, because all of these arrows are going to cancel out. So it's nonpolar as a result. There's no dipole moment, no positive, negative charge. The only thing left we need is the bond angles. So if you look, here's your tetrahedral. Here's your bond angle. So tetrahedral forms a 109.5 bond angle between every bonded atom. Okay. And there you go. All right, Br2. This is 7. 7 times 2 is 14. So bromine bonded to bromine. When you count all those up, it's going to be 14. This is linear. It's the same thing bonded to the same thing, so it is going to be nonpolar. There's no dipole moment. There is the bond angle is going to be 180 because that's what linear is. It's just 180 degrees from one to the other. No positive or negative charge because it's nonpolar. Okay, COS. This is 4, 6, and 6. The total being 16. So carbon's going to go in the center. Oxygen, sulfur. Give everybody 8. My total number now is 20, right? When I add up all the dots and lines here, it's going to be 20. So I'm over by 4. So I need to add 2 bonds and then erase dots to get back to 8. So here I have a linear structure because there's no lone pairs on the center atom. Linear has a bond angle of 180 degrees. The electronegativity difference between carbon and sulfur, they're both 2.6. So this bond right here is actually nonpolar. Oxygen is 3.5. So your bond arrow is going to point towards the oxygen. So you do have a dipole moment. It's going to point here. This is your partial negative. This is your partial positive. I think that's everything that we needed. Yep. Okay. All right. So the arrow O's points to the more negative side of the molecule, and the positive side of the arrow is on the positive side of the molecule. SCl2, 6, 7, 20. Sulfur in the middle. Okay, so this is bent, so we want to show this is bent. Let's see if I could do this. Nope. All right, I'm just going to redraw it. Okay, so we have our bent shape. I'll make this a little bit nicer. All right, so between chlorine and sulfur, chlorine's more electronegative, so the arrows are going to go towards it. So here's your dipole moment. This is a bent shape. If we look at the FET, if we look at the FET here, here's a bent structure, and you can see the bond angle is 109.5. So just like the tetrahedral bond angle, bent is the same between the two bonded atoms. So it's 109.5 angle. Got everything, bond angle. This is going to be polar. Sorry, I did not mention that on the previous one, but it should be known with that dipole that it's going to be polar. All right, I think we got it. All right, HI. Magic number's 8. Hydrogen's 1, iodine's 7. So there's 8 right there. This is going to be having a dipole towards the iodine. Positive, negative, partial. This is linear. 180 degrees because it's just a line. It's just linear. It is polar as mentioned. And yeah, there we go. All right, selenium, nitrogen, fluorine. Okay, so selenium 6, nitrogen's 5, fluorine 7. So we have 18. Ooh. Okay, 18. Selenium in the middle, nitrogen, and then fluorine. Give everybody 8. So this is 20 right here, so we're over by 2. So we're going to double bond the nitrogen because fluorine only really likes to form one bond. Because how do we know that? Fluorine has 7 valence. It has 1 bond available. So it would like to just form a single bond. Nitrogen can form up to 3. So that's why we give the double bond to the nitrogen. All right, so this number is 20. We're over by 2. We added the double bond. So now we got to go back and erase dots. Actually, I'm going to erase the bottom one. There we go. So now the new shape is going to be bent. Okay, now this is a unique bent because there's only one lone pair. So take a look at the bond angle. This is a bent shape with 2 lone pairs. With 1 lone pair, it's kind of like trigonal planar's bonding angle. So it's 120. So 120 degrees. This is going to be polar because you have 2 different things bonded. It's a bent shape, so the arrows won't cancel even if they were the same. Nitrogen is also having an arrow here, so you have positive, negative, your partial negative, partial positive side. Yeah, I think that's it. Okay. Getting close here. Silicon disulfide. 4, 6 times 2 is 12. So this number is 16. Silicon in the center. This number is 20. So we're over by 4. So I got to add 2 bonds. And then I got to go back and erase dots. So now everybody has 8. This is linear because there's no lone pairs. Sulfur is more electronegative, so the arrows will point here, but it's going to be non-polar because those arrows cancel out, so there's no net dipole moment. Since it's linear, the bond angle is 180 degrees. And I think that's it. I've done a bad job of assigning polar and non-polar. I'm realizing back here, if it has this dipole moment, that means it's polar. Okay. Glad we cleared that up. All right, SB and I. Antimony is in nitrogen's column, so it has 5. Iodine is 7 because it's a halogen. 7 times 3 is 21. So this number is 26. Give everybody 8. All right, when I count them all up, this is going to be 26 right here. So this is actually going to be trigonal pyramidal because that lone pair repulses these iodines down. All right, so now the iodine is more electronegative than antimony. The shape is trigonal pyramidal, so there's nothing to cancel out these downward bond arrows. So your dipole moment points towards the iodine, meaning this is polar. Okay, this is our first trigonal pyramidal, so let's look. Okay, so trigonal pyramidal, 3 things bonded, 1 lone pair. You're going to see it's 109.5 for its bond angle. All right, we did it. SeCl2. Selenium is 6, chlorine 7. Total number is 20 because that's going to be a 14. So okay, this number is 20 right here. So this is your very standard bent shape. Chlorine's definitely more electronegative than selenium. So your dipole moment's going to point towards the chlorine. This is polar, if you haven't figured it out, because it has the dipole moment. The shape here is bent. Sorry, I've done a bad job of writing down the shape type, maybe. But I've been saying them out loud, so hopefully you've been listening. So it's polar, it's bent. The bond angles for a bent shape. So here's bent, but it has 2 lone pairs, is 109.5. Okay. Ooh, PBR3. It's a good one. 7, 5, 21, 26. Ooh, where have we seen a 26 before? It's going to be just like this one. Watch what we can do. Watch what we can do. Almost got all of it. Duplicate. Bring it down. And we can just adjust this how we need it, right? The center atom and the outside atoms are just different. So we have phosphorus, bromine, bromine, bromine. Same thing here. Phosphorus, bromine, bromine, bromine. Love it. And bromine and phosphorus behave in the same direction with those arrows. So more electronegative, electropositive. 109.5 for the bonding angle. It's polar. Hey, look at that. Ooh, SiS2. Let's look. 4, 6. This can be 12. So this is 16. Where have we seen a 16 before? Oh, wait a minute. Those are the exact same questions. Okay, I'm just going to say refer back to D because you already did it once. Yeah. All right, we're not going to do this one again then. That's a duplicate. That's a mistake. Our bad. Antimony and fluorine. So antimony is 5, fluorine 7. So the total number is 12. SB bonded to F. Give everybody 8. So this number is 14. So this is going to be double bonded. Definitely polar because fluorine's the most electronegative thing on the table. Positive side, negative side. The bonding angle is 180 because it's linear. And I think that's it. think. I hope. Did I cover everything on here? Bond angles, the separate shape, molecular geometry. Great. Man, we did it. Okay, I'm going to pause before we get to part 4.